y double dashed minus 10y plus 25y equals 3x squared. Let's have a look at this one then. Okay, so let's do the YH first then, subproblem. The associated homogeneous differential equation. So we've got here y double dashed minus 10y dashed there plus 25y equals 0. So write down the associated auxiliary equation, line lambda squared minus 10 lambda plus 25, which will factorize onto it, minus 5 and minus 5. So let's put them in. So it's a repeated root case. Here lambda equals 5, doesn't it? That's the root. Repeated root case, so it's case 2. So case 2 gives then, and we can now write the solution for YH is equal to, it would be AE to the lambda, which is 5x, plus BX e to the lambda, which is 5x. There we go. Good. Now, that's YH done. So now we turn our attention to YP. The right-hand side here is 3x squared. So we want to try YP equals. Okay, so let's go down to our table and look up what we need to try here. Here's what we've got, something x squared. And we need to try this as a possible solution and find out a, b, and c. 3 values to find. So try y equals ax squared plus bx plus c. Okay, then y dashed will equal 2ax plus b, won't it? And y double dashed, if we differentiate this, we just get left with 2a. So substitution then gives, so what have we got then? Y double dashed. We're trying it in YP, so don't forget that's a 3x squared there from the line above. So maybe bring that back into view. So substitution, y double dashed, which is 2a, minus 10y dashed, minus 10 of y dashed, 2ax plus b, and then plus 25y. There's y, ax squared. Oops. Ax squared plus bx plus c. And that all equals 3x squareds, doesn't it? So we can equate coefficients now in x squareds, x's and constants, or we can input values of x in this to find out the values of a, b, and c. So I think the first thing to do is look at the x squared terms, the coefficients. Here the only x squared term is here, 25a. So we've got 25a is equal to, there's no other x squareds, is equal to 3. So a equals 3 over 25. Now what's best to do next? Yeah, let's look at the x's, because they seem okay as well. So how many x's have we got? Minus 20a here, minus 20a, and then we've got 25b plus 25b equals 0. So that tells us then, leave the 25b where it is, and move the minus 20a across to plus 20a. And then all we need to do is move the 25 from times to divide, 20a over 25, which equals 4/5, doesn't it? 4/5 of a. A is 3 over 125, so we're going to end up with 12. 4 times 3 is 12, and then 25 times 5 is 125. So there's b. So now we just need c, which is here. So if we put in x as 0, or basically the constants, so x equals 0, then 2a. We're going to get a minus 10b here. And then these will be 0. 25c is equal to 0. So then 25c is equal to, now move these two things over, 10b minus 2a when you flip the signs. 10b is 10 of these, which is 120 over 125. And then 2a will be 2a minus 2a will be 2 3s are 6, so it's minus 6 over 25. So that tells us then that 25c is equal to this, divide by 5 top and bottom. 5 goes into 120 24 times, and 5 goes into that 5 times there. So 24 takes 6 25ths is 18 over 25. So that will give us c is equal to 18 over 25 squared, which is 625. So I'll put that in the box. There's c. There was b, and here was a. I'll put this one in a box as well. So we know the values of a, b, and c now. So we know yp. So we can write down the final solution now then. Here's yh, a e to the 5x plus b x e to the 5x. So let's write down our answer then. So y is equal to yh plus yp. So that yh was a e to the 5x plus bx e to the 5x plus ax squared, and a had the value 3/25 x squared, plus b, which is 12 over 125, 12 over 125 x's, and then c, c is equal to 18, so it's plus 18 over 625 as a constant, that's c. So there we are.